Good evening, students. So last class we have finished synopsis, right? So today we'll start with the MCQs. Okay. So I have some previous years MCQs. So we'll just go through that. Okay. So this is our first question. So the question is the correct sequence of bond enthalpy of CX bond is. Okay. So what do you mean by CX bond? What is CX? CX is nothing but it is a alkyl halide, right? It is a alkyl halide. CX bond, right? CX bond is nothing but alkyl halide. Now, any alkyl halide, that is, they have taken what? Which alkyl alkyl group they have taken? Methyl, okay, methyl, and there are different halide groups. So these are what? So okay, so these are different halides. So X can be your fluorine, chlorine, bromine, and iodine. Okay. Now, when you are writing the halogens, okay, so we in the group, right, they have arranged like this: fluorine, chlorine, then comes bromine, and then comes iodine. So what will happen to the size? Yes, what will happen to the size as you go down the group? You know that what will happen as you go down the group, the size will go on increases, right? So down the group, so when you're talking, as you're going down the group, what will happen? Size will increase, right? So down the group, so first what will happen? So down the group, as you go down the group, what will happen? Number of shells increases, right? So as the number of shells increases, what will happen to atomic size? Atomic size also increases. Okay. So this is the first reason. So you can see that there will be different shells. So for F, there will be only K shell. For C, K and L. Okay, then K, L, M. And for this, K, L, M, N. Okay, so like this. So these are the different shells which will be there. Okay. So as you go down the group, what will happen? As you go down the group, the number of shells increases. So as a result, atomic size increases. So now you know, as the atomic size increases, what will happen to the bond which is formed between CH3, Cl? Now fluorine. So what is bond enthalpy? You know what is bond enthalpy? So it is the energy which is required to break a bond. Okay. So the energy which is required to break. So you have to write the current sequence of bond enthalpy of CX bond. Okay. So the energy which is required to break down the this. Okay. So here how it will be, just see CH3. If I take fluorine, so CH3F. Okay. So smaller. So the bond is stronger, right? So bond is stronger. And what will happen to the size? As the size is small, okay, as the size is smaller, so the bond also will be smaller. Now, as you go down, which is the next one? Cl. So Cl, as you know, as you go down the group, what will happen to the atomic size? It will increase. So this bond will be slightly larger. Okay, so this is also little larger. So the bond which is present between the CH3Cl will be slightly little bigger. Okay, then again CH3Br. Okay, when you're talking about Br, so again, as you go down the group, what will happen? Size will increase. So the bond between the alkyl halide, it will also be slightly more. Okay, so this will be slightly more than Cl. Then what will happen to CH3I? So here also, so as iodine is, as you go down the group, the number of shells increases, right? So for fluorine, how it will be? Okay, only one shell. For chlorine, okay, two shells will be there. Then bromine, okay, like this. So as you go down the group, number of shells increases. So what will happen? The bond length also goes on increases. So remember that as the bond is longer, okay, so it is weaker. So long bond is weaker and it will be easy to, it is easy to break it. Okay, so remember that. So as the size increases, the bond between the atom, it goes on increases. So as the bond is longer, what will happen? The bond is weaker. Okay, so it is easy to break. So bond enthalpy, you know, it is nothing but it is the energy which is required to break a bond. So bond enthalpy is, so it goes on decreasing. Okay, so bond enthalpy, how it will be then? CH3F, okay, will be greater than CH3Cl. Okay, then is greater than CH3Br, which is greater than CH3I. So which is our correct option? Yes, our correct option is C. Okay, so C is the correct option. So you know that. So as you go down the group, what will happen? Atomic size go on increases. Okay, so as the bond between the atom also goes on increases. So for CH3F, as the fluorine atom is smaller in size, so what will happen? The size will be small. The bond length will be small. What is bond enthalpy? Bond enthalpy is nothing but it is the amount of energy which is required to break the bond between the two atoms. Okay, so as the small bond is present between the two atoms, the bond will be stronger. Okay, as you go down the group, okay, as the atom size of the atom increases, the bond size goes on, the bond length goes on increases. Okay, as the bond length increases, what will happen? As the bond is longer, it will be weaker. Okay, and it will be easier to break. So C is the correct answer. Okay, so we'll go for the next one. So this was the question asked in NEET 2021. Okay. So we'll go for the next one. The reaction of C6H5CH double bond CH3, okay, with HBr produces C6H5CH2CH2Br. Then, so these are the four products. Okay, so benzene ring with a substituted Br and CH double bond CH3. Then C option C6H5 CHBr CH2CH3, and D option C6H5 CH2 CH3 Br. Okay, so can you tell what will be the answer? You can try. So this is based on methods of preparation. Okay, so this is a question based on methods of preparation. So here, so we'll first see the reaction. So they have, okay, a benzene ring is there. C6H5 is nothing but benzene ring with what? CH double bond CH3. Okay, so it is reacting with what? It is reacting with HBr. So this is a what? It is an unsymmetrical alkene, right? Across the double bond, right? So there are unequal number of carbon atoms, so one phenyl group, right? So, so this is an unsymmetrical alkene. So whenever you have an unsymmetrical alkene, what you will follow? You will follow the Markovnikov's rule, right? So Markovnikov's rule is what? The negative part of the alkyl halide will be added to the carbon having less number of hydrogen atoms, right? So here, if this is a double bond, now this is a double bond. So across the double bond, both the carbon atoms are having same number of hydrogen atoms, right? So, so this, uh, so what is that? Markovnikov's rule does not state over here. Okay, so next what we can see here, so on what principle it might be based? So here it is based on the carbocation formation. Okay, if we proceed via Markovnikov's rule, okay, if we proceed via Markovnikov's rule, you can see that what is Markovnikov's rule? The negative part of the alkyl halide will be added to the carbon having least number of hydrogen atoms. But across the double bond, both the carbons are having same number of hydrogen atoms, right? So, so in this case, it is not, you cannot decide the products. So this is overruled. Okay, so the principle which can decide the product is based on the stability of carbocation. Okay, stability of carbocation. So we'll see now how do you find the stability of carbocation here. So if this HBr, so first the attack takes place. So I'll show you here. So HBr, okay, so that is CH double bond CH3 in the presence of HBr. So first, what will happen? Your hydrogen will attack. Okay, so the hydrogen, if it attacks here, so if it attacks on this particular carbon, just see. So this will be, so what will be the product? It can be CH2, CH plus and CH3. So here the hydrogen is attacked on this particular carbon, okay, on this particular carbon. So when it attacks this particular carbon, so there will be formation of carbocation. So this is one product, okay. Then second, if it attacks this particular carbon, the second carbon, so what will be the product? So it will be CH, okay. Then your CH2, this will be CH3. So if the attack is on this particular carbon, so here the H will attack this particular carbon. Okay, here the H has attacked here. So these are the two products. So this is A and B. Can you tell me in which particular reaction it is more stable? Which intermediate is more stable here? Yes. Can you guess it? In which particular product it is more stable? So B, okay. So A and B, out of A and B product, okay. So the B is more stable. B is more stable. Why? Because this positive charge which is there on this particular carbon will be resonance stabilized. You know, there is benzene ring, right? So here it will, so this the carbocation or the positive charge will be resonance stabilized. Okay, so because of the presence of this benzene ring, okay, so this positive charge is directly attached, right? That carbon is directly attached to the benzene ring. So so this positive charge is resonance stabilized. Okay, so and you also you can see that here beside the positive charge, alkyl group is also there, and here aryl group is also there, right? So it can be stabilized. So phenyl group and alkyl group both can be stabilized. So the positive charge can be stabilized by both the group. So this is the attack of H. So first the attack of H, it produces what? Carbocation. Now what will happen? So there is a electrophilic center, right? So now the nucleophile will attack at this at this particular carbocation. Okay, now we'll see what will be the now we'll see what will be the okay. So this is first. So now I'll just erase it. Okay. So we got the two products. Okay, we got the two products. Now what will happen? Now here, the next is what? Attack of Br minus. So this Br minus will attack here. And what product you will get? What product you will get? You will get CH, okay, Br, CH2, CH3. So can you tell me which is the answer? So if I write the condensed form of this, okay, it will be C6H5, right? CH, Br, then CH2, CH3, which is the option? Option number, yes, option number C, right? Option number C. You can see that option number C is the correct answer, right? C6H5, C6H5. So benzene ring is nothing but C6H5, right? Then which is connected to what? CH. So CH, then this is connected to Br. So Br, then CH2, CH3. So option C is the right answer. So because of unsymmetrical alkene, we saw that whether it is following Markovnikov rule. But Markovnikov rule, what it states that the negative part of the alkyl halide should attack the carbon. Okay, it should get attached to the carbon having least number of hydrogen substituents. Okay, but here both the carbon atoms are having same number of hydrogens. So so this principle is not applied here. So next what we'll see? Next we'll see the stability of carbocation. So based on the stability of carbocation, we can decide the attack of the nucleophile. So first the what proton will attack each carbon, okay, at the across the double bond. So based on the what you say, stability. Okay, so in the first case you can see that the positive charge is just attached to what? This carbon is attached to two alkyl groups. Okay, so this cannot be more stable. But here in the second case, you can see that the positive charge, okay, the carbon is carbon having positive charge is directly attached to a benzene ring. So this can be resonance stabilized. The positive charge present on the carbon can be resonance stabilized. So this will be more stable. So the B is more stable than A. So the attack of the nucleophile will take place at this particular center, and you get this particular answer. So C6H5, CH, CH2, CH3. Okay, so this is the answer. So C is the option. We'll go for the next one. So in the replacement reaction, okay, so this is a replacement reaction. So the replacement reaction is Ci plus MF giving you CF plus Mi. The reaction will be most favorable if M happens to be. Okay. So how is the reaction? Can you tell what type of reaction is this? What you can see here? What type of reaction is this?
SN2, ma'am.
It's one of a name reaction. Okay, it's one of the name reaction. You can see this is what Ci is what iodine, right? Iodo, and this is what F is what fluoride. So iodine, okay, here what is happening? There is a replacement reaction between iodine and fluorides. So which name reaction is there? Which name reaction is that? We have studied name reactions, right? Yes, it is Schwarz reaction, right? It is Schwarz reaction. So in Schwarz reaction, we are preparing fluorides from iodo, okay, iodo groups. Okay, so here from alkyl iodoalkanes, okay, we are preparing what? Fluorides, okay. So Schwarz reaction. Now, the reaction will be most favorable if M. So what we are taking, we are attacking the iodoalkanes with metal fluorides. Yeah, right. So they are asking, so the reaction will be most favorable if what happens if the M will be. So which metal it should be? Okay. A, sodium, B, potassium, C, rubidium, D, lithium. So they are asking which metal you can use here. Okay. So here highly soluble. So what we are making use of for Scott's reaction, we are making use of highly soluble metallic fluorides, right? We are making use of this metallic fluorides so that the metal should be a large size. Okay, so whenever the metal, if it is of large size, then what will happen? It will be more soluble. So if you take the metal which is of larger size, then the metallic fluorides are most soluble, so that the replacement reaction takes place easily. So if you see these are all alkali metals. So lithium, right? Then comes sodium, then comes potassium and rubidium. So as you go down the group, what will happen? As you go down the group, it will increase. Okay, so the atomic size will go on increase. So if you take the metal which is of large size, then it will be highly soluble. So which is the metal? It is rubidium. Okay, so it is rubidium. So C is the answer. So if you use rubidium, so what will happen? They are highly soluble. So they are highly soluble. So in the replacement reaction, if you use rubidium fluorides, okay, so then they are highly soluble. So the replacement reaction will takes place. So, okay, so this is the answer. We'll go for the next one. So when chlorine is passed through propene at 200 degrees Celsius, which of the following is formed? A, PVC, B, allyl chloride, C, propyl chloride, D, 1,2-dichloroethane. Okay. Now here, so what is propene? What is the structure of propene? So the structure of propene, so the question is the propene. Okay, propene is reacting with chlorine at 400 degrees Celsius. Now what is propene? Propene is 3, right? CH22. Is it propene? So this is a propene molecule. Okay, so this is a propene molecule. Now propene molecule, if it reacts with Cl2, if it reacts with chlorine, okay, in the presence of what? At 400 degrees Celsius. The temperature condition is given as 400 degrees Celsius. So what will happen here? So at 400 degrees Celsius, substitution occurs, okay, instead of addition. So instead of addition, what occurs here? Substitution reactions occur. Okay, that is instead of electrophilic substitution reaction, okay, sorry, electrophilic addition reaction, what occurs here? Free radical substitution takes place. Free radical substitution takes place. Now, free radical substitution means what? What will happen here? So here, okay. So at this particular temperature, substitution occurs. Okay. Instead of addition. So what will be the reaction? Okay, so it will be CH, Cl, CH2, CH, double bond, CH2. Okay, so this is a allyl chloride. This is what? This is a allyl chloride. Okay, so this is a allyl chloride. Okay. So answer is what? Allyl chloride is what? Halogen atom is attached to the carbon which is next to a carbon-carbon double bond, right? Okay, so what is allyl chloride? Halogen atom is directly attached to the carbon which is directly attached to a which is halogen atom is attached to a carbon which is next to a carbon-carbon double bond. Okay, so this is a allyl chloride. B. Okay, so the answer is B. So the next question is the major product formed in dehydrohalogenation reaction of 2-bromopentane is pent-2-ene. This product formation is based on. Okay, what do you mean by dehydrohalogenation? Hydro means what? Elimination of one hydrogen. Dehydro. Halogenation means one halogen group. Okay, so that is it is one what is that? Dehydrohalogenation means what? One hydrogen and one halide. So this is okay. So this is a dehydrohalogenation. So what they are asked, the major product which is obtained, okay, when 2-bromo, so we'll just see 2-bromopentane. So what is the structure of 2-bromopentane? So the structure of bromopentane is CH3, CH2. Pentane means 5 carbons, right? CH2, CH2, CH. Okay, so this is a pentane. So this is 1, 2, 3, 4, 5. So this is what? 2-bromopentane, right? So 2-bromopentane, the major product formed in dehydrohalogenation. Dehydrogenation means what? Elimination of one hydrogen bromide. Okay, so dehydrohalogenation. Now so there are two ways from which you can remove. So one, you can remove from this particular carbon, right? So you can remove the hydrogen from this particular carbon, and one more, you can remove the hydrogen from this particular carbon. Okay, so you have this. Okay, so if I remove it from this particular carbon, what product I'll get? CH3. I'll write it. Okay, just see, I'll write it more. So it was what? C. Okay. C H H C H H H, right? So I'll just write it more simpler way. Okay, so 1, 2, 3. Okay, now here you can see now. So there are two ways. So here also you can remove, and from here also you can remove, right? Now if I want to remove it from this particular carbon, what will be the answer? So it will be CH. Okay, so from here one hydrogen, if it goes, just a second. So if this hydrogen goes like this, so this hydrogen and this bromide will go. Okay, you can see this. So this is like this, hydrogen goes and this bromide also will go. What will be left? So CH, this will be double bond. Okay, then CH, CH3. Right. What is the name now? So answer 1, 2, right? 3, 4, 5. So this is pent-2-ene. Okay, if I remove the hydrogen from this particular carbon. Now, if I remove the hydrogen from this particular carbon, just see, what it will be. So just see, I'll write here. So just see, so CH3, okay, then CH3, CH2, CH2, then CH double bond, CH2. So what is the name? 1, 2, 3, 4, 5. So this is pent 1 in, right? So which is the correct answer? This, right? So this pent 2 in. So which rule it is? So it is Setzef rule. Okay, what do you mean by Setzef rule? So Setzef rule, Setzef rule states that so always the hydrogen is removed from the highly substituted. Okay, the alkene is formed from the highly substituted alkyl group. So because of the presence of highly substituted alkyl group, okay, it follows the Setzef rule. Now, when you're talking about Huckel's rule, it tells you about what? It tells you about aromaticity. Okay, it tells you about aromaticity. So this rule is not applicable. Hunt's rule, it talks about the degenerate orbitals. Okay, degenerate orbitals. You know this Hunt's rule, right? Hunt's rule, what is that? So electrons filling will takes place in the degenerate orbitals singly. First, it will be singly filled, and then the pairing will takes place. So this is Hunt's rule. So this also rule is wrong. Then Hoffman rule, it tells you about less substituted alkyl group. So the product is from the less substituted alkyl group. So here you can see there are highly substituted alkyl group, right? You can see here highly substituted alkyl groups. So here also alkyl groups are there. Here also alkyl groups are there. So this is formed in between the highly substituted alkyl group. But by this, if you remove, there is no highly. It is less substituted alkyl group. So Hoffman rule, it depends upon the less substituted alkyl group. So the answer is B. Okay. Yes, Priyanka, Jyoti, and Vita have answered it right. Good. Okay, so we'll go for the next one. Elimination reaction of 2-bromopentane to form pent-2-ene is. So another same question. Okay, same 2-bromopentane. So 2-bromopentane is what? CH3, CH2, CH2, CH, Br, and CH3. So this is what? 1, 2, 3, 4, 5. Okay, it is pent. Okay, so that is, sorry, 2-bromopentane. Okay, 2-bromopentane elimination reaction. So it is what? 1 HBr is removed. Okay, so this is what? Hydrohalogenation reaction. So one is what? It is hydrohalogenation. Okay, it is hydrohalogenation. Dehydrohalogenation. Okay, then from which hydrogen it is removed? From the beta, right? Alpha, beta hydrogen, right? This is alpha, this is beta. So beta elimination reaction. Yes, it is beta elimination reaction. So it follows the beta elimination reaction also, right? Then another is what? It is the product is formed from the highly substituted alkene. So more substituted alkene is formed. Okay, so it follows what? It follows the Setzef rule. So our option A is the right answer. Yes, so it follows beta elimination. What is dehydration? Dehydration means removal of water molecule. Are we removing any water molecule? No. So it follows beta elimination, it follows Setzef rule, and there is a dehydrohalogenation in this particular reaction. So it is A, B, and C. Option A, right? Yes, Anvita and Jyoti have answered it right. Okay, so we'll go for the next one. So the hydrolysis, okay, the hydrolysis reaction that takes place at the slowest rate among the following is. Okay, so these are the 4 reactions which they have given. So amongst the following, you have to tell. Okay. So just a second. So the hydrolysis reaction that takes place at the slowest rate among the following is. So there are 4 options, 4 reactions are given. Okay, this is the first reaction. So you can see that hydrolysis, okay, always the hydrolysis reaction, it depends upon the hydrolysis reactions are nothing but they are called as SN1 reactions. Okay, SN1 reactions are called as hydrolysis reaction. So you know that in SN1 reaction, what is SN1 reaction? Substitution nucleophilic unimolecular reactions. Okay, so in SN1 reaction, the rate of the reaction, okay, rate of the SN1 reaction, it depends on what? It depends upon the rate or concentration of only substrate, right? What is substrate? Substrate is what? The carbocation formation, right? So carbocation. So in hydrolysis reaction, what is hydrolysis reaction? It is SN1 reaction. So SN1 reaction, it depends on what? It depends on the rate of SN1 reaction. Okay, it is directly proportional to the substrate, okay, or the carbocation stability. I'll write it as carbocation stability. Carbocation stability. Okay, now, so you know, if the carbocation is more stable, okay, if the carbocation is more stable, okay, then the reaction will proceed fast, right? Now we'll see in each reaction. Now, if we take the first reaction, so this is the leaving group, right? So the our leaving group is Cl. So what will happen? So I'll just write. So I'll write the carbocation formation in each case. Cl. Okay, so what will happen here? So carbocation formation will takes place after this leaving group is left. So here this is a carbocation formation, right? So this is carbocation. So this is the first step. Sorry, this is the for first reaction. Now first reaction, you can see that the carbocation is directly attached to a sp carbon, right? sp2 carbon. So this is a sp2 carbon. So sp2 carbon, what will happen? It will decrease. It decreases the stability. Okay, it decreases the stability because this is a sp2 carbon. So because of the sp2 carbon, it decreases the stability. So we'll go for the next one. So that is CH3 CH2 Cl in the presence of aqueous NaOH. So what will happen? Oh, okay, so this will be CH3 CH2 plus, right? So here what will happen? So there are, so it this proceeds via, it depends on hyperconjugation. Okay, what do you mean by hyperconjugation? No bond resonance. Okay, so there are three hydrogen atoms, right? These hydrogen atoms are involved. Okay, so this will stable this positive charge. This will okay, this will keep this positive charge in stability. So your hyperconjugations and inductive effect plays a role. Okay, inductive effect. So this is also more stable. Okay, then next is CH2 double bond CH, CH2 Cl in the presence of aqueous NaOH. What the reaction takes place? So here it will be CH3 CH CH2 plus. Okay, so here what you can see, so there is double bond is involved. Okay, double bond is involved, so there will be resonance. So the charge can be stabilized by resonance. So remember that if the charge is stabilized, okay, what will happen? The reaction will proceed fast. So here we have to see if the stability of the carbocation is decreased, then the reaction will be slow. So they have asked out of the four reactions, which reactions will take place at a slower rate. So here it will go at a higher rate. Okay, the reaction will proceed via fast rate. Why? Because this charge is stabilized by the resonance. Okay, so there is a resonance. So this also is okay. Then next we'll see. Next is what? CH2Cl, CH2 aqueous NaOH, CH2 plus. Okay, here also resonance, right? So this positive charge is attached to what? This carbon is attached to phenyl group, right? So here also resonance. So this will proceed via a faster rate. So the carbocation is stabilized here in this case. Okay, so this also will be this will go at a faster rate. Here also this carbocation is stabilized by this double bond. Okay, so resonance because of stability, so this also will undergo a faster rate. So here what is involved here? Stability. Okay, so there are three hydrogens. So these hydrogens, so these are hyperconjugation, that is no bond resonance. Okay, so the movement of this hydrogen, okay, so it stabilizes this positive charge. So here also due to plus, it is said to be a plus side effect, or it is hyperconjugation. Okay, so this also the carbocation stability is there, so it will undergo fast. Here the charge is directly on the benzene ring. So this is a sp2 carbon. So because of sp2 carbon, what will happen? The stability will decrease. So our option is the correct. So as the stability of carbocation decreases, what will happen to the rate? Rate will go on. Okay, as the the it will undergo via a slower rate. Okay, so as the stability of this particular carbocation is decreasing, the rate at which this reaction takes place will be very slow out of the four reactions. So our option A is the right answer. Okay, understood. So in the other cases, if the you can see that the positive charge is stabilized by resonance or inductive effect or hypoconjugation in each case. Okay, so because of that, if the carbocation is stabilized, okay, then what will happen? It will what will happen? The carbocation, if it is stabilized, then the reaction will go at a faster rate. Okay, as compared to A. So A is the correct answer. So we'll go for the next one. So the compound A on treatment with Na gives B, and with PCl5 gives C and D. C, okay, with PCl5 gives C. B and C react together to give diethyl ether. A, B, and C are in the order. So you have to tell which is A, what is B, and what is C. Now, what is our A? Yes, A will be our ethanol. Okay, if we take ethanol as A, so ethanol, if we treat it with sodium, okay, if we treat it with sodium, so I'll write this as A. So this I'll write it as A. So if you treat ethanol with sodium, what you'll get? You will get C2H5ONA, right? So you'll get what? C2H5ONA. So this is sodium ethoxide. This is what? This is our B, right? So this is our B, sodium ethoxide. Now what they're given? The compound A on treatment with Na gives B, and B and with PCl5 gives C. Okay, now with A, so with A, I have to treat it with PCl5. Understood? See, the compound A on treatment with Na gives B, and with PCl5. So this only A will react with what? It will react with PCl5. So if it reacts with PCl5, it will undergo a substitution reaction. So C2H5Cl. Okay, so this is our what? It will give you C. So this is our C. Understood? So first A will react with sodium to give you B, and this A again it react with PCl5 to give you C. Okay, A will react with PCl5 to give you C. Now B and C will react together to give you diethyl ether. Now you see B is what? C2H5ONA plus what is our C? C2H5Cl. Okay, so this is our B, this is our C. So what will happen? Okay, so this Na, okay, and this Cl will get combined, and what you'll get it? Diethyl ether. So C2H5O, okay, and C2H5. So this is what? This is diethyl ether. Okay, so what are A now? So A is ethanol, B is what? B is sodium ethoxide, and C is ethyl chloride. So which is our option? Option D. Right, understood? So option D. Option D is the right answer. So ethanol. So so the compound A, when treatment with sodium, it will give you sodium ethoxide. Again, compound A, if it reacts with PCl5, gives you ethyl chloride. Again, B and C, if it reacts, it will give you diethyl ether. So you have to write what is A, B, and C. So A is ethanol, B is sodium ethoxide, and C is ethyl chloride. Okay, so this is the correct order. Understood? Understood the MCQ still here? Any doubt? Okay, so we'll go for the next one. Ninth one. Okay. The compound C7H8 undergoes the following reaction. So the compound is given C7H8. Okay, C7. So remember, always when more than C6 are there, that means there is an involvement of benzene ring. Okay, always when more than C6, the carbon atoms are there, then there can be involvement of a benzene ring. Okay, C6H6. Now we have to see the double bond displacement. We need to know how many double bonds are there. So there is double bond equivalent. Okay, if a formula is given and you want to find the structure, so you have to first see if there are double bond present. Okay, so how do you calculate double bond? So this is the formula: C minus H by 2 plus N by 2 minus X by 2 plus 1. So this is the formula to calculate the double bonds, okay, in a particular compound. Okay, so this is the double bond equivalent to calculate the number of double bond. So now I will just substitute carbon. How many carbon atoms are there? 7. Minus hydrogen atoms are 8 by 2 plus nitrogens are 0. Right. Then halogens are there? No. So minus 0 plus 1. So this will be how much? 2 ones are 2 fours are. Okay, so this will be 7 minus 4 plus 1. So this will be equal to 4. So 4 bonds are present. Okay, 4 bonds are present means what? There will be, if benzene, if I take benzene, so here only 3 bonds are present, right? So this is what? This is H6, right? So again, 1 C, and how many are left? 3. So it is CH3. So this is the compound. Understood? So 4 bonds are there. 4 bonds means what? Out of 4 bonds, if I take one benzene ring, so there are what? 3 bonds. So this is what? C6H6. Now we are left with what? 1 carbon and how many hydrogens? Okay, C6H5, sorry. If I take one more this, okay, so it will be CH3. So this will be CH3. So plus CH3. So this will be total what? It will be C7H8. So this is our compound. So what is the name of the compound? Yes. What is the name of the compound? It is toluene. Right. This is the compound name is what? It is toluene. Now this toluene, so what they have done? They have treated it with 3Cl2 and heated. Okay. So I'll write the reaction again properly. So toluene. Okay, toluene is what? It is Cl2 and heated. So what is happening here? So this is what? This is a nucleophile, right? Benzene. Benzene, whenever there is a double bond, okay, whenever there is a double bond, it will go what? This will undergo substitution. Okay, why it will undergo electrophilic substitution? So whenever, so it will undergo a electrophilic substitution due to high electron density. So this is a electrophile, so this can attack this, but electron due to high electron density, but this will undergo of you are heating it. So in the so whenever you are heating halogen in the presence of whenever you are heating okay, in the presence of any halogen, so it will undergo what? It will undergo free radical mechanism. It will undergo free radical mechanism. So whenever you are heating, okay, so that is Cl2. So 3 molecules of Cl2. So where the attack will take place, it will not attack the benzene ring. It will attack the CH3. Okay, it will attack the CH3. So how is the reaction takes place? So the reaction will takes place like this. So it will be C. Okay, so here. So this will be CCl3. All the hydrogen atoms will be replaced by what? All the chlorine atoms. Okay, so this is our compound A. This further treatment with Br2 and Fe. Br2 and Fe, so it will undergo a electrophilic substitution reaction. Okay, electrophilic substitution reaction means it will undergo a bromination because you have taken what? Bromine. So it will undergo electrophilic substitution reaction, electrophilic substitution reaction, that is it will undergo a bromination. So what will happen? See that bromination. Okay, so CCl3. So what is present here? See here, CCl, Cl, Cl. Okay, so these are what? Cl are what? Electron withdrawing group. Okay, these are electron withdrawing group. So what it will do? So because of the presence of electron withdrawing group, okay, so the electrons will be withdrawn from ortho and para position. So whenever electron withdrawing groups are there, the electron or the electron density will be withdrawn from ortho and para position. So because of that, it will reduce more. Okay, so the stability, it will reduce more. So in this case, what will happen? The incoming electrophile, so which is our electrophile, that is Br. So incoming electrophile will get substituted at what? It will get substituted at meta position. Okay, so our this will be, so it will be CCl3 and this will be Br. Okay, so this is our B. Okay, this is our B. This is further treated with Zn and HCl. What is Zn and HCl? Zn and HCl, it is a reduction. Okay, so this will undergo reduction. So reduction means what? What will happen? There will be addition of hydrogen. So what will happen? These again Cl groups will be replaced by hydrogen. So this is the CH3 and Br. So what is the name? What is the name of the compound? So which is the compound C? It is metabromotoluene. It is what? Metabromotoluene. Okay, so these are the steps you have to follow. So in the first step, what is happening? All the Cl2. Okay, so halogen is present. So because of the presence of halogen, what is happening? It will undergo a free radical mechanism. So it will undergo free radical mechanism when you are heating it with 3 moles of Cl2. So all the CH3, okay, H3 atoms, that is hydrogen atoms, will be replaced by the chloride. So what product you will get? It is trichloromethylbenzene. So what is the name? It is trichloromethylbenzene. Okay, it is trichloromethylbenzene. So this trichloromethylbenzene, it will undergo further electrophilic substitution reaction. That is, in the presence of bromine and Fe, it will undergo bromination. It will undergo what? It will undergo bromination. So which is our electrophile? Br. So Br, as there is a presence of this one electron withdrawing group. So electron withdrawing group, what it will do? It will withdraw the electron towards itself. So the electrons will be withdrawn mostly from the ortho and para position. You know which is ortho. This is ortho. Okay, these are ortho and these are para position. So the electrons will be withdrawn from ortho and para position. So it will reduce more at that position. So because of, so in this case, what will happen? The electrons, as the electron density is withdrawn from ortho para position, so the incoming electrophile will attack at the meta position. Okay, so meta position, so it will form a CCl3. That is, what is the compound name? This is 1-bromo. Okay, 1-bromo 3-trichloromethylbenzene. Okay, so this is the compound B name. Okay, so methyl benzene. So this on further reduction, what is zinc in the presence of HCl? It is acting as a reducing agent. Reducing agent means what? It will add up the hydrogen. So all the Cl atoms will be replaced by hydrogens. Okay, so the answer, the option C, okay, that is C. Compound C is nothing but metabromotoluene. So option A is the right answer. I hope it is clear. Yes. Okay. So we'll go for the next one. So last question, we'll solve this and we will stop. So the question is, identify A and predict the type of reaction. Okay. Instead of this, we'll go for the next one easier. This will take. So consider the reaction. Consider the reaction. So this is a reaction, which is our reaction CH3, CH2, CH2Br plus NaCN. Okay. So it will give you what? It will give you CH3, CH2, CH2CN plus NaBr. Okay. So the so they have asked this reaction will be fastest in A. So these are the list of solvent given. A is ethanol, B is methanol, C is NN-dimethyl formaldehyde. Okay, that is DMF, and D is water. So this is what type of reaction? Okay, so just see at the reaction and you can say, so it is what? It is a SN2. It is a nucleophilic substitution bimolecular reaction, right? It is a SN2 reaction. So what is SN2 reaction? The attack of the nucleophile at the substrate, that is alkyl halide, takes place from the behind, okay, and it will undergo a transition state, okay, it will undergo via a transition state. So the attack, right, so this, so leaving group and this attack of the nucleophile and the breaking and making of the bond takes place simultaneously towards a transition state, and this is the product what we have obtained. So this is what it is, a SN2, that is nucleophilic substitution bimolecular reaction. So what are the factors of SN1 SN2 reaction? So it depends upon the substrate, it depends upon the nature of substrate, it depends upon the nucleophile, okay, it depends upon the nature of nucleophile. Then next is it depends upon the solvent, nature of solvent. Then next is it depends upon the leaving group. Okay, it depends upon the nature of leaving group. Now here they have given the list of the they have given the list of the solvents. So so which solvent we make use here? We make use of polar aprotic solvent. Polar aprotic solvent. Now what are polar aprotic solvent? So solvent in which hydrogen atom does not react in any of the reaction. Okay, so here hydrogen atom, they do not react in any of the reactions. So we are making use of polar aprotic solvent. Now we'll consider first ethanol. So what is the structure of ethanol? Clear till here, right? So this is a bimolecular reaction. So these are the factors here. They have given the list of solvents. So we have to consider the solvents. So what type of solvent is we are making use in SN2 reaction? It is polar aprotic solvent. What do we mean by polar aprotic solvent? Solvent in which the hydrogen atom does not react with any of the reaction conditions. Okay, so that is polar aprotic solvent. So if we consider the first one, that is, if we consider first one, that is ethanol. Okay, if we consider ethanol, so ethanol, what is the structure? It is CH3 CH2OH. So what is present? So hydrogen is present. So hydrogen will participate in SN2 reaction, right? So it is not so hydrogen will participate, right? In this hydrogen will participate. So this is what it is, a polar protic solvent. So polar protic solvent, because hydrogen will participate. So SN2 mechanism is not possible. Okay, then next is what? Next we'll go to methanol. What is methanol? Methanol is CH3OH. Okay, here also hydrogen is present. So this is also a polar protic solvent. So polar protic solvent, so SN2 mechanism is not possible. So whenever hydrogens are involved, then SN2 mechanism is not possible. Then the next is what? NN dimethyl formaldehyde. Okay, so what is the structure? It is H, C double bond O, N, then CH3, CH3. Okay, so this is, so the there is no okay, hydrogen, free hydrogen available. So this is what? This is a polar aprotic solvent. So this is polar aprotic solvent. So here SN2 reaction is possible. Okay, so there is no involvement of any free or OH groups. Okay, you know that if hydrogens are involved, what will happen? It will show hydrogen bonding, right? So this will also not possible. So this is answer C is the correct answer. Okay, the next one is what? So correct answer is C. That is N dash dimethyl formaldehyde. Because here what? It is a polar aprotic solvent, because there is no free hydrogen available. Okay. So SN2 mechanism is possible. Then next is water. Water also, you know, H2O, right? Hydrogen bonding is involved. So SN2 mechanism is not possible. So this is also polar protic solvent, because there is free hydrogen. Okay. So the answer is C, right? Understood? I hope this is clear. Yes, the questions till now, whatever we have discussed, is it clear? Okay. Okay then. So I hope Okay, so I hope it is clear. Okay, so we'll stop the session here. We'll continue in the next class.